Right, so in this worksheet, I'm going to talk about mole and gram worksheet. Now, first of all, make sure that your answer leave a scientific notation, but then of course, you're not necessary to leave all the answers scientific notation. Well, how do you know you need to leave a scientific notation? It's actually when you go back to the previous worksheet, mole and particle. I did that. When do you need to leave a scientific notation? Is when your positive exponent is equal to bigger than 3, or if your negative exponent is smaller or equal to -3. That means that your number is too small or too big. Then you want to leave a scientific notation because you don't want to write so many zero. And when you don't need to leave a scientific notation, is like when you have exponent -2, -1, 0, 1, or 2. That means the answer is not too big, not too small. For example, 100 or like 0.01, you can just leave it as it is. If you want, you can leave it as scientific notation, but you don't have to. Okay. All right. So in this worksheet, I'm going to introduce the mole and gram. So first of all, make sure that scientific notation is first step, and then number 2, you're going to leave your answer is 2 decimal places. That will be the last step. And also, you must always have answer, unit, what it is. Okay, there's 3 things. So your answer, unit, what, compound. Now, first of all, I'm going to introduce the term called molecular mass, mm. Okay, mm. So mm, the unit is gram per mole. Okay, that means how many gram in 1 mole. So sometimes people call molar mass, sometimes people call molecular weight. Now, how you're going to do it is on your periodic table, you will find those atomic weights, the same thing. It's the one that on the top with the 2 decimal places. Okay, so for example, this is the given to you is I have the reference answer H3PO4, so we're going to separate them. I have 3H, I have 1P, I have 4O, and then I'm going to find the numbers from the periodic table. So let's say hydrogen is 1.01, I will put it in, and P is 30.97, and oxygen, be careful because this is a 16.00. You don't want to just write 16, you have to write 2 places. So the best way to do is copy whatever from the periodic table. Don't write 16, it's wrong. It should be 2 digit, 16.00. All right, you write it out and then you multiply them out. Make sure you include both the word. Okay, you don't want to just start with this and then jump to this answer because we need this information on the next worksheet. Okay, and you add them up, you get 98.00 gram per mole H3PO4. Again, you don't want to write 98, it's wrong. It should be 98.00 gram per mole H3PO4. So let's do one question number 5. Okay, so I got 2 Mn and then 7 Se. Okay, so Mn, the molecular weight is 54.94. And then Se, I got 78.96. So I multiply them, and I will get 109.88, and then 552.72. All right, so when I add them up, I will get 6626 from the calculator. If I add them up, I will get this. But you don't want to just leave it as the answer. You have to put a 0 because it's always 2 decimal places. And the unit is gram per mole, and it's Mn2Se7. Okay. Now here on number 6, just be careful. I have 2 nitrogen and 8 hydrogen because you have the 2 vertices, the 2 outside. Okay. Now let's talk about the next part is the mole to gram. Now 1 mole equal how many molar mass? I can express is either the mole on the top, the gram on the bottom, or the molar mass on the top, the mole on the bottom. How do I know which one is which? I don't remember any of the formula. All I remember is what do you want to cancel. Now why do I say that? Because molecular mass, molecular is actually tell you mole. Mass is gram, so it must have gram, and mole could be like gram on the top, mole on the bottom, or the other way around. So how do you know which one's which? Is you want to cancel the unit. So when we set up the diagonal, the Superman, the diagonal must have the same unit and the same compound, so that I can cancel. Then I don't need to worry about remember the formula. All I remember is just the unit. Or actually, you don't need to remember the unit because you can figure out molecular is mole, mass is gram. Okay, now here's the example. So how many moles of 98.3 gram aluminum hydroxide? So you first of all want to find the MM of that. So you find out we have 1 Al, we have 3 oxygen and 3 hydrogen, and we find these 3 numbers from the periodic table, which is okay, these numbers, the one with the 2 digit. Right, it's the Al here, okay, and then the oxygen is here. You find them from the periodic table, okay, and you put them in, you find the molecular mass. And then next, you're going to set up the Superman. I get 98.3 gram aluminum hydroxide. Now here, I want to cancel my gram, right? I want to cancel my gram. Then my gram will be on the bottom. Now, which one I know is the gram? You see the gram here is linked to 78.01. So the gram is 78.01, not 1 gram. All right, and then here has the definition per mole, meaning per 1 mole. So 1 mole on the top because I want to cancel my gram. So these two must have the same unit. Okay, so I'm going to put the gram on the bottom and 1 mole on the top. I'm going to cancel my gram and then AlFH3. I cancel them. So I will have 98.3 times 1 mole divided by 78.01. And then I punch in calculator. I got this number and the mole. Now this one is between 1 to 9.999, so I'm okay with the scientific notation. I don't need to move the decimal point. When do you need to move decimal point is when it is not between 1 to 9.999. Okay, when do you need to move decimal point is this not in between 1 to 9.999. So you have to move the decimal point and add the exponent back. Now here I'm happy. The only thing I'm not happy is the rounding. This must be in 2 places. So after I round to 2 places, I got 1.26. And the unit is mole, and the name is AlOH3. So I'm going to do one question here. How many moles are in 680 grams of copper 2 hydroxide? So we first, I'm going to find out the MM of Cu parenthesis OH3. Okay, I got 1 Cu, I got actually 3 oxygen, and I got 3 hydrogen. Okay, so I can find it from periodic table. It's 1 times 63.55, 3 times 16.00, and then 3 times 1.01. I multiply them out. Okay, I multiply them out, and then when I add them up, I think I get 97.57 gram per mole CuOH2. Okay, so that's my MM. Then I'm going to do the Superman to change it from gram to mole. So I start with 680.0 gram Cu parenthesis OH2, and then I'm going to do this. Okay, I draw the Superman. Now here, what do I want to do? I want to cancel the gram. So here I must put the gram. So which was my gram? 97.57 gram. It's got to be on the bottom. Then 1 mole will be on the top. Here he has the definition of per mole. So 1 mole Okay, so I'm going to use my black pen to cancel my unit and the compound. So I'm going to cancel my gram and then I cancel my calcium, the copper hydroxide. Alright, so now after that I'm going to write out the equation, the math. Okay, so 680.0 times 1 mole divided by 97.57. Okay, so 680.0 times 1 mole and then divided by 97.57. Right, so then now I put it into calculator. I will find out that I get 6.969355 mole. Okay, now do I need to change to move the decimal point? No. Again, the only time you move the decimal point is when this number is not between 1 to 9.999. But since this one is between 1 to 9.999, I don't have to move decimal point, but I have to think about the rounding. So I have to round it. After I round it to two places, I get 6.97, and my unit is mole, and Cu when this is OH2. So we put the 6 back on here. All right. Now I'm gonna go to the back. Now the back is actually opposite of what you learned. Okay, so which is meaning the multigrams, the same idea. I'm going to use green pen. So multigram, for example, how many grams are in 4.50 mole of sodium fluoride? So first you find the Mn of NaF. Okay, so just do the same thing. You find the Na, you find the F, you put it in, you multiply them out, and you add them up together. And then next, you're going to set up Superman. So I put 4.5 mole NaF here. Now again, what do you want to do? I want to cancel my mole NaF. So that means my mole will be on the bottom. So here, my mole is actually 1 because per 1 mole. So 1 mole NaF on the bottom, and then 41.99 gram NaF on the top. Again, I want to cancel my mole. So these two must have the same unit, which is the mole. I cancel my mole and NaF, and then I write out the equation, 4.50 times 41.99 gram over 1, and then I got 188.955 gram. Now this number is not between 1 to 9.999, but I don't have to change its scientific notation, because when I change it, I will get exponent will become 2. So you can actually change the scientific notation, which is 1.89, okay, times 10 to the power 2, or you can just round it like that. It should become 188.96, because this one, the exponent is 2. I don't have to leave in scientific notation. You can, but you don't have to. Okay, so either you come to this, or you can write equal to 1.89 times 10 to the power 2 gram. So either way will be fine. Either one answer will be fine. Okay. Now let me try the number 5. How many grams of in 0.02 mole of beryllium iodide? Okay. So we need to find the Mn of BeI2. Okay, so I get 1 Be, I got 2 I. So my Be is 9.01. My I got 2 of them, 126.91. So I multiply them out, I got 9.01, and then 253.82. Okay, if I add them up, I will get 262.91 gram per mole BeI2. Okay, measure these two places. Okay, now the second step is I'm going to set up Superman. I got 0.0200 mole BeI2. Okay, now again, what is the target? My target is I want to cancel my mole BeI2. So here, diagonally must be mole BeI2. So which number should I get? I should get actually 1 mole BeI2. So 1 mole BeI2 will be on the bottom. So what will be on the top? Will be the gram on the top. 262.91 gram BeI2 on the top. Then I'm going to use my black pen to cancel my mole and my BeI2. Cancel both the unit and what it is. And then I write out the equation, 0.0200 multiplied by 262.91 gram. And then I divide it by 1. And then I punch in calculator, I will get 5.258 gram. Okay, now again, this number is between 1 to 9.999, and I'm happy with the exponent. I don't need to move decimal point. The only thing I have to do is rounding. So after I round, I get 5.26 gram BeI2. Okay, so again, when do you need to move decimal point is when this is not between 1 to 9.999, and you have to move decimal point and add the exponent. But when you add the exponent, if you find out your exponent is like 2, 1, 0, negative 1, negative 2, you don't have to leave it as scientific notation. You can leave it as the original number like this. Okay, or if you want to change to scientific notation, fine, but you don't have to. But here I don't need to move my decimal point because this number is already between 1 to 9.999. The only thing I have to do is do rounding.